My name is Lindsay Whaley. I'm the Associate Dean for International and Interdisciplinary Studies and Professor of Linguistics and Cognitive Science at Dartmouth College. Today I'm going to be speaking with Ross Virginia, who's the Myers Family Professor of Environmental Science and the Director of the Arctic Institute at the Dickey Center. Ross, you've had a long career looking at desertification and arid lands ecosystems. When did you get involved in the arid lands of Antarctica?
Well, I started working in hot deserts. I've always been drawn to sort of big, open, dry ecosystems where you can see the sky, where you can see the soil, where you can see the rock. These open landscapes have always attracted me. And I started working in deserts of California in the Southwest. And our science was really looking at how life in soils controls the cycling of the essential elements that run the earth, carbon and nitrogen. And what we were finding is that looking at life in the soils, we couldn't separate the influence of plants from the life directly in the soil. And we started thinking about, well, where could we go? Where could we find a place without plants that still had life in soil and soil where we could really look more directly at the microscopic animals in the soil ecosystem and find out what they do. And we were at a meeting and sort of describing this dilemma, and someone who worked in Antarctica said, I've got the place. You got to go to the dry valleys. Got to go to McMurdo Station. That's the place for you. It's no higher plants, the simplest ecosystem on the planet. The biodiversity in the soils is extremely limited.
As you transition from the hot deserts to the Antarctic, what sort of adjustments did you have to make in terms of your own approach to your research?
The difficult thing, obviously, in Antarctica is the unpredictable environment there. Wind, weather, the logistics of getting there, and everything that seems pretty easy in most ecosystem studies, just using routine equipment, becomes very difficult in Antarctica. Batteries don't last.
Right.
There's a lot of blowing dust and dirt, which just wreaks havoc on electronics. And then the rates of the biology are really, really low. So we're always kind of pushing techniques right to the edge, which after a while actually becomes part of the challenge of working there. It's not only sort of physically challenging to be there, it's technically challenging to do the science.
Would you say that your research has primarily been involved with the consequences of climate change?
To a large extent, yes. I've been working with a very large team of scientists as part of a program funded by the National Science Foundation called LTER, and that stands for Long-Term Ecological Research. And there are about 23 sites in the LTER network around the U.S. There's one in the Pacific, Puerto Rico, 2 in Alaska, and there's two sites in Antarctica. And the goal of these LTERs is to bring a team of scientists together to take apart the entire system to see all the pieces work. So in our system, we're working at trying to understand how climate impacts glaciers, which melt and feed the streams, which then fill the lakes. And then I'm looking at how the soil ecosystem interacts with all of those pieces.
Now, obviously, your scientific results have potential implications for public policy. Have you been involved at all in terms of on the policy front and its interaction or potential consequences or ameliorating effects for global climate change?
Well, the Antarctic work is really focused mainly on the basic science of how these ecosystems operate and trying to understand what they're about. And I participated in the Millennium Ecosystem Assessment, which was a global effort to understand how all the important ecosystems function and then how humans are impacting them. And that was the backdrop for the Millennium Assessment Goals of the UN. So I've participated in the science studies which then feed into that. More recently here, at Dartmouth, I direct the Institute of Arctic Studies for the Dickey Center. And that's really where my policy interests are playing out. It in many ways has been part of what I've done for a long time. Even when I was working on desertification, I was interested in policies around management of arid lands. And I became interested in how ecosystem science contributes to policy decisions. And in that process, I became involved with a group called the Association of Ecosystem Research Centers. And it's a nonprofit representing universities and research groups engaged in science and its connection to policy. And I eventually became president of that group for a while. And we worked directly with Congress. We provided sort of white paper informations around science and its impact on policy. So I've always had that interest. What's been exciting here at Dartmouth recently is through the Dickey Center is the chance to kind of do that more directly through conferences, workshops, engaging students. And so I would say my research, I have this strong basic science interest, but I'm more and more interested in the human connections to that science.
Yeah. Would you describe your tack as it relates to the public policy front as one more of advocacy of certain positions or more as a resource and information provider?
Probably somewhere in between that. I think the science has responsibility to do science well and to provide information of high quality, and that's obviously what we try to do. I think it's also important, though, to understand how policy works and what science policymakers need, and more particular, what science do communities that are experiencing environmental change or environmental damage, what do they need from science? We're working a lot right now in Greenland with the Inuit Circumpolar Council and the University of Greenland. And Greenland's the front lines of climate change right now. And a lot of Western scientists go into Greenland, they do their science, and then they fly home and they publish their papers. And that's traditionally what we do, and that's tremendously important. That's how we advance science and knowledge. But I think we realize there's a growing need to directly involve the people in the communities and the governments that are experiencing this change in the work and asking them, what science do you want?
You've recently participated in the proposal for an IGERT grant, which has been received. Is that connected into some of this work in policy and environment?
Yeah, I think it very much is. I think as I've sort of watched my own career development from scientist to scientists interested in policy to scientists really wanting to help students understand earlier what policy is about. That's what this IGERT program is. IGERT's a NSF graduate training program. It's a network of such programs around the U.S. and it's to identify places that have a particular strength or excellence and then help them grow in interdisciplinarity, help them form new partnerships, and help train the new next generation of leading graduate students. The IGERT here at Dartmouth is focused on polar environmental change. And what we want to do is train world-class polar scientists and engineers. So they have to know the science, they have to know the techniques, they're going to be publishing in the top journals, they're going to be contributing to the front lines of science. And we're doing that now, that's what we've done. What we want to add on now is an opportunity for them to understand the human dimensions of that work, understand the moral and ethical responsibilities of partnering and working with people in the North. How do you do that? How does traditional knowledge inform Western science? And I think ultimately what we're challenging our students to do is perhaps ask different questions of their science, making their science responsive to the receivers of the science.
You've been in Antarctica now for quite a while. What do you see in terms of the next couple of years, the questions that you're trying to answer in terms of your own research?
Right. Well, we've been working in a part of Antarctica that's sort of the newspaper headlines a few years ago say defies climate change. We all think of the world as warming uniformly, but in fact, there are regions of the world that have been cooling, actually in response to human disruptions to the atmosphere. But the region I've been working in has been cooling over the last 2 decades. And we have a pretty good sense of how this ecosystem has changed over the last 100+ years. The first person to enter the dry valleys was Robert Falcon Scott in 1903. And he commented on he called it the Valley of the Dead. He commented on the lifeless appearance of the landscape. And we've come to learn that the place is very much alive. There's life in the lakes and the streams and the soils. There's life in the ice. And what we've been finding over the last number of years of research down there is that small variations in climate, cooling in our case, result in very large changes in these ecosystems. And polar scientists call this polar amplification. If you look at an ecosystem that's poised on the edge of either melting or freezing, a 1 degree change in temperature can completely change the structure and the functioning of that ecosystem. So you might think that a cold, isolated place like Antarctica wouldn't be sensitive to small changes in temperature, but in fact it's exquisitely sensitive to temperature.
Who are you working with on this particular project?
Well, there's a great group from Dartmouth, my lab, this year going down to the ice with me. This will be my 15th season since 1989. I have a postdoctoral scientist, she's a soil ecologist, Becky Ball. I have a PhD student in the ecology program, Elizabeth Traver. Then I have a Dartmouth undergraduate, or at least she's currently in Africa on her foreign study program. She'll be graduating from Africa. She's flying back to the States. She has 48 hours to change clothes, and then she flies to McMurdo. So there's 4 on our team. But I work very closely with a great group from Colorado State University.
Yeah, and it seems my sense these days is that science increasingly is becoming so interdisciplinary, it's hard to even answer or ask the right questions without teams like that. Does that seem to be the case in terms of polar research as well?
Absolutely. For example, I've been working recently with our glaciologists down in the dry valleys, because the life and actually soil particles get blown up onto the glaciers and they melt into the ice, and then you get these communities, little microcosms of these little melt pools forming within the glacier that are alive, and they're cycling carbon and nitrogen, and eventually those nutrients break out of the glacier and feed into the streams, and then they affect life in the lakes. So what we're finding is that there's no isolated system here, and the beauty of Antarctica is that the biodiversity is so low there compared to most ecosystems that we can actually track what's going on. If I were to walk out on the Dartmouth Green and dig up a handful of soil and try to identify what was in there, I'd be spending the next several weeks on one sample. And we have a much simpler system. We can move through questions more quickly in Antarctica.
Tell me a little bit about your involvement of Dartmouth students in your research and in terms of your public policy work.
Sure. Well, I teach, last several years I've been teaching a course called From Pole to Pole, Environmental Issues of the Earth's Cold Regions. And I've been attracting 60 to 75 students a year to that class. And one of the things that they have to do is they have to do some original research using we have a world-class collection in polar, particularly Arctic literature, primary materials left to Dartmouth by Willem Stephenson, the famous Arctic explorer who was in residence here in the 50s and 60s. And a lot of students really get excited after they begin to have an opportunity to work with these old letters and photographs and materials that describe the way the Arctic was, and then they have to write about what's happening today. And so students get engaged in that. They come to me and say, well, what can I do? And I say, well, we have a Dickey conference coming up. We need someone to help with the conference, with research. It's an opportunity to sit in on a conference and meet the leading people in the world and begin to network with them. On the Antarctic research, typically students find me, a lot of students find me. They all want to, can I carry your bag? Can I cook for you? How do I get to Antarctica? And generally, that winnows down a little bit when I say, well, probably the first thing you need to do is weigh and grind soils and clean glassware and hang out in my lab for a while, see if this is for you. And they do that. They come in and they work and they become part of the research group. And often there's a chance for them to go south with us. Katie Moreland, who'll be with us this year, sort of went through that same process. And then sometimes when they come back from Antarctica, then they continue as a research assistant in the lab. So Dartmouth students are great. I mean, there's no opportunity that they won't sort of search out.
What would you say are Dartmouth's strengths in terms of becoming a center of excellence, an international center of excellence in terms of polar research, and particularly the connection to global climate change and affecting public policy?
Right. Well, I mean, we were really set up by John Dickey and Willem Stephenson when they lobbied hard to have the U.S. Army Cold Regions Research and Engineering Lab located here in Hanover in the 60s. And so we already have the U.S. government Center for Cold Expertise right here in town with us. And I think that one of the things that we're trying to do is to sort of harness the power of that workshop with what we have at Dartmouth. When you combine those two together across our departments and what you have at Krell, we really are a world center for polar expertise. I think that we haven't done as well perhaps in showcasing that or communicating that. I think we've been busy doing the work. I think the opportunity now, we're in nearing the end of the International Polar Year, which is a celebration of international collaboration in polar science. And Dartmouth Krell have worked together on a number of projects associated with that. I think we've improved our visibility in this work, and I think we've started some significant new work as part of that. Mm-hmm. So I think really we have this community that's been here a long time. I think the Dartmouth's commitment to the Dickey Center has grown. Dickey Center commitment to the Institute of Arctic Studies has grown. And I think in that process, we're really making some really significant steps forward.
Yeah. Would you identify any particular challenges that you see in the foreseeable future in terms of either carrying out the research in the cold regions or in terms of bringing the scientific information into the policy debate?
Well, I think the challenge for all science in the upcoming short term is the global economy. I think what is important for science to do is show that science matters and that science is connected to human well-being. And to the extent that we can do that, then our funding for science will remain strong. Mm-hmm. I think you can't pick up a newspaper these days and not see an article about the melting of the ice, the rising of the sea level, all these changes that are happening to the north that are generated by what we do in Hanover. So I think people are looking more and more towards, well, what can I do personally, or what can my community do to enter into these solutions? And I think that's really the challenge for science, and that's where institutions like Dartmouth, I think, have a really special role in helping educate very broadly, not just our students, but the public, about what our options might be.